Good afternoon, scholars. I hope all is well with you. This is Mr. Lowen. I'm giving you a quick review of the algebraic expressions and solving linear equations that we had already went through over the course of the first semester. Now, this will be gone over during the first couple of days of the second semester. Of course, it will not go into as much detail as we will in this video here. So if you want the full amount of examples for you to use to help you review, this is the video that you're going to use. So again, today we're going to look at evaluating expressions, simplifying expressions, and solving equations, all of which we did in the first semester. So let's start with algebraic expressions. Of course, when you have an algebraic expression, it's a combination of numbers, operations, variables. It's made up of 5 particular parts. First thing are terms, which are the parts of an algebraic expression separated by a plus or minus sign. So in this expression, 8x squared minus 4x plus 3, there are 3 terms. 8x squared minus 4x and positive 3. So you have 3 separate terms. The variable is the letter that represents what you don't know. So in that case, x represents your variable. Exponent, value indicating how many times to multiply a base. So the 2 here is your exponent. That's telling you to take x and multiply it twice. So that's x times x. Constant is a number that is not attached to a variable, which in this case would be the 3. So the 3 would be a constant. Last but not least, coefficient. Number that's in front of a variable, this number is being multiplied to it. So in this case, there are 2 coefficients. 8 would be a coefficient. It is multiplying to the x squared. And 4 would also be a coefficient. Now keep in mind, since that 4 has a minus sign in front of it, that would be read as negative 4. So the 8 is a positive 8, the 4 is a negative 4. Remember, when you have a number, you always take the sign that's in front of it. So again, that's a quick recap of the basics of an algebraic expression. Let's go down to operations involving integers. So, integers are simply all the positive numbers, all the negative numbers, and 0 being in the middle. So when we're dealing with operations with integers, have to know how to find the opposite. Opposite is same number, different sign. So the opposite of negative 6 would be positive 6. Opposite of positive 3/5 is negative 3/5. Simple as that. Absolute value is the distance a number is from 0. Key thing with absolute value is always positive answer. Always gives you a positive answer. So the absolute value of negative 9 is 9. It's 9 spaces from 0. The absolute value of negative 3.25, so that's the notation for absolute value, would be 3.25. It doesn't matter if the number is given to you as a fraction, as a decimal, or as a whole number, absolute value's definition is still the same. Now, we go to adding integers. When you're adding integers, if the signs are the same, then you add the numbers, keep the sign. So examples 1 and 2 highlight that specifically. 14 plus 7, 21, you're adding 2 positive numbers. Negative 8 plus negative 11, negative 19, you're adding 2 negative numbers. If the signs are different, then you subtract the numbers and you keep the sign from the bigger number. So in example 3, 5 plus negative 12, 2 different signs. So you would do 12 minus 5, 7. 12 is the bigger number, and since it has a minus sign in front, it's negative. So that means it would be negative 7. Same rules apply for example 4. Negative 17 plus 21. So you would do 21 minus 17, which is 4. 21 is the bigger number. And since it's positive, your answer would be positive. And that's how adding would work. Subtraction. Subtraction follows the rule of keep, change, change. Keep the first number, change subtraction to addition, and then change the second number to the opposite, and then follow your rules for adding. So for each of the 4 examples, each example shows the process. So with example 1, 7 minus negative 3, keep the first number, change subtraction to addition, take the second number and make it the opposite. So the opposite of negative 3 would be positive 3, and then you add the way you normally would. 7 plus 3, 10. Example 2, negative 9 minus 10. Keep the first number, change subtraction to addition. 10 would become negative 10, and then you would follow the rules for addition. Examples 3 and 4 work the same way. Finally, multiplying and dividing integers. In this case, you multiply or divide the way you normally would. If the signs are the same, then the answer would be positive. If the signs are different, the answer is negative. So be careful that you don't confuse the rules with multiplying and dividing with the rules for adding. 2 different sets of rules. So in the case of example 1, 9 times 2 is 18, but you have a positive number times a negative number. Positive times negative is negative. So that's how you get negative 18. Negative 7 times negative 5. 7 times 5 is 35, and a negative times negative is positive. That's why it's positive. So again, that's how the rules work. So far, that's algebraic expressions and looking at the basic rules for integers. Those were done very, very early in the first semester. As we keep going, we go to evaluating. Evaluating is when you're actually doing computation for an expression. So to evaluate, substitute the values of the variables into the expression, and that's if necessary. If you don't have any numbers to plug in, if you just have all numbers, then you can just start your work. Solve out the expression using the order of operations. So order of operations, you probably remember as please excuse my dear Aunt Sally. First step is your parentheses. So inside or underneath parentheses, square roots, or the absolute value. Then exponents. But exponents also includes square roots, and it also includes anything that is absolute value. Then multiply or divide from left to right. This is one concept that I know a lot of people struggle with in the first semester. Multiply or divide from left to right. Or multiply or divide. That means if division comes first, you got to do it first. The end. Lastly, add or subtract from left to right. Same thing. If subtraction comes before addition, so what? You do the subtraction first and then do the addition second. That is what it is. So for example 1, 48 divided by 2 squared times 3 minus 15. So parentheses, there's none, so we don't have to worry about it. Exponents, you have 2 squared. So 2 squared is 4. 48 divided by 4 times 3 minus 15. Now we multiply or divide. So you see 48 divided by 4 and you see 4 times 3. Remember, you always go from left to right. So that means 48 divided by 4 gets done first, which is 12. And then 12 times 3, which would be 36. 36 minus 15 leaves you with 21. So that's your final answer. Again, it's important, especially in high school math, you show your work. Don't just put 21 and expect you're going to get full credit for the problem. That's not how it works. So, example 2. So we have this following expression. Same rules apply. First step, work out anything inside or underneath the parentheses, the square roots, or the absolute value. Now, of course, for this particular problem, I put one of each. That's where you start. So, 25 minus 9 is 16, so you have the square root of 16. Minus 7 minus 11 is negative 4. 5 minus 14 is negative 9. So we have all that taken care of first. Now we do our exponents, the square root, and the absolute value. So the square root of 16 is 4 minus negative 4 squared. So negative 4 squared is the same thing as negative 4 times negative 4, which would give you positive 16, plus the absolute value of negative 9 is how far negative 9 is from 0. It's 9. So now we're set up, ready to keep going. There is no multiplying or dividing, so that works. Adding or subtracting from left to right. So that means 4 minus 16 gets done first. 4 minus 16 is 12, negative 12. And negative 12 plus 9 leaves you with negative 3. And that completes the problem. So the key thing with order of operations is you must go from left to right. You have to go from left to right, and not just go in whatever order you feel like. It doesn't work that way. So when variables are in the problem and they give you a number to plug in, the number goes in first. So example 3. 5g minus 1 and g is equal to 10. So take 10, plug it in for g. That's 5 times 10 minus 1. A number next to a variable means no multiplication. That means multiplication. So 5 times 10 is 50. 50 minus 1 is 49. That finishes off the problem. If there's 2 variables in the problem, okay, that's nice. Take each number, plug it in for the variable that it goes with. So that's 3 times negative 5 minus 2 times negative 2. So if we work it out, 3 times negative 5 is negative 15. Minus 2 times negative 2 is negative 4. And then we solve out the problem. So remember, subtraction. So keep, change, change. Negative 15 plus 4, negative 11. So again, integers, positive and negative numbers are going to happen. So if you struggle with positive and negative numbers, make sure you review the section on operations with integers. Positive and negative numbers are going to happen. So finish off evaluating, do 2 more examples. b squared minus 4ac. So we have three variables we have to take care of. Okay. A is 4, b is negative 5, c is negative 3. First order of business, plug in everything. We go interference on the board right there. Negative 5 squared minus 4 times 4 times negative 3. So, negative 5 squared, so negative 5 squared gives you positive 25 minus 4 times 4 times negative 3. 4 times 4 is 16. 16 times negative 3 is negative 48. That's 25 minus negative 48. And then we solve out the problem. So, keep, change. 25 minus 48 give us 73. And that's it, that's our final answer. So again, once you plug the numbers in, it's still an order of operations problem. Once the numbers get plugged in, it's still an order of operations problem. So let's look at one more example. That one being example 6. y2 minus y1 over x2 minus x1. That is the slope formula that we worked on before the semester break. Nonetheless, take each number, plug it in. You end up with y2 is negative 8. So negative 8 minus 4 over x2 is 5. x1 is negative 4. So that's 5 minus negative 4. So we plug in everything first. Now we start solving it out. Negative 8 minus 4, negative 12. 5 minus negative 4 will give you 9. So you have negative 12 divided by 9. It's a fraction. You can reduce it. Divide the top and the bottom by 3. So you get negative 4 over 3. And that's your final answer. My advice is very, very simple. Do not change a fraction to a decimal if it's a decimal that's not going to stop. That is nice and easy. For example, 1/2 is 0.5. If you gave that as a decimal, that's okay. Negative 4 over 3 is negative 1.3 repeated. That's not a nice decimal to be rounded. So, unless it's going to be a nice decimal, don't round it. Don't give it as a decimal. Give it as a fraction. So that's evaluated. Simplifying algebraic expressions. So simplifying involves distributive property, involves combining like terms. There is a little bit of division involved, which we'll do in the last problem. So, when you're simplifying an algebraic expression, first thing is do the distributive property. So distribute means take whatever values on the outside, directly attached to the parentheses, and multiply it in. Combine like terms is adding and subtracting. Adding and subtracting like terms. So in order for terms to be like terms, we have to have the same variable and the same exponent. Same variable, same exponent. So let's do a couple of examples of combining like terms. 8a minus 5 plus 9a plus 7. Remember, every term takes the sign that was in front of it. So that means this 8a is positive, 5 is negative, the 9 is positive, the 7 is positive. So when you're combining, the a's go with the a's. So it's 8a plus 9a. So that means negative 5 plus 7 have to combine with each other. 8a plus 9a is 17a. Negative 5 plus 7 is positive 2. 17a plus 2. Now, do not attempt to put that together. 17a plus 2 is not 19a. That's 100% incorrect. You can't put those together. 17 has an a attached to it. The 2 did not. So you can't just add those together because it doesn't work that way. So let's do another example. We have 11b minus 18 minus b plus 13. So one thing to keep in mind here, this letter b doesn't have a number in front of it. If there's no number in front of a variable, it is understood to be 1. So for some of you, it might help you to put the number 1 in front of the variable. If you don't think it will help you, that's fine. Just know that there's a 1 in front of it, and you have to treat it that way. Same rules apply. So 11b minus 1b. So 11b minus 1b, and then negative 18 plus 13. 11b minus 1b is 10b. Negative 18 plus 13 is negative 5. That is your final answer. So remember, these two cannot be put together, so you cannot make this 5b. That is 100% incorrect. That is 100% incorrect. And since these notes are going to be available to you, let me put 19a over there and cross it out. Those are incorrect. So that's basic combining like terms. Distributive property is when you multiply whatever's outside, whatever's attached to the parentheses, you multiply it through. Multiply it through. So example 3, you have 7 times 3n minus 2. So that means 7 has to be multiplied times 3n, and 7 has to be multiplied times negative 2. So you multiply it times everything inside the parentheses. Seven times 3n is 21n. 7 times negative 2 is negative 14. Those are not like terms, so that's your final answer. So that ends up being your final answer. Example 4 kicks it up a little bit. 5 parentheses n plus 3 plus 1/2 times 10n minus 8. So there's 2 sets of parentheses. So the parentheses multiplies times whatever is in front of it. So the first parentheses would multiply times 5. That's 5 times n, and 5 times positive 3. And then 10n minus 8 would multiply times 1/2. 1/2 times 10n, and 1/2 times negative 8. Then we start our simplifying. 5 times n is 5n. 5 times 3 is 15. 1/2 times n is 5n. That's positive 5n. 1/2 times negative 8 is negative 4. Now that we have some like terms, we combine our like terms. So 5n plus 5n is 10n. Negative 15 minus 4 gives you positive 11. You have 10n plus 11. Again, simplifying, that's already one of the concepts, one of the primary concepts from the first semester, and we're going to continuing to use it throughout the second semester. So 5 and 6, two more examples of simplifying. So 1, we have 2 parentheses. We just did an example like that. However, now we have a variable being multiplied times itself. So anytime you take a variable and multiply it times itself, that's that variable squared. So if we do our distributing, that's 2n times n, and 2n times positive 3. Again, there's interference there, I apologize. Negative 5 times n, and negative 5 times positive 3. So let's do our multiply. Remember, there's no number in front of a variable. It's understood to be 1, so I'm going to put a 1 in front of each of the n's. 2 times 1 is 2. N times n is n squared. 2 times 3 is 6, and then the n just comes down. Negative 5 times 1 is negative 5, and the n comes down. Negative 5 times positive 3, negative 15. So before you finish the problem, look at the problem, see if there's anything that can be combined, which, there you have it. So 2n squared plus n minus 15. That's that. Problem's over. And that's that. Problem's over. So the last problem deals with division. Last problem deals with division. So 35p minus 28 divided by 7. So in this case, you take each part at the top, each term at the top, and divide it by 7. So that's 35p divided by 7 minus 28 divided by 7. And then you simply divide them out. 35p divided by 7 is 5p minus 28 divided by 7, 4. So you're left with 5p minus 4. So if you're dividing by a single term, pretty simple to divide out. Pretty simple to divide it out. So, the last review concept for this set of notes focuses on solving linear equations. So, solving linear equations, big concept for Algebra 1. You need to know how to solve an equation in order to be successful in Algebra 1. That's pretty much a non-negotiable there. So, an equation, mathematical statement says that 2 expressions are equal. So, x plus 8 equals 5, that's your equation. Solution is the answer that's going to make it true. So, negative 3 would be the answer because it satisfies the equation. So when you solve an equation, that's going to require you to use inverse operations, distributive property, combining like terms. So let's look at the steps for solving the equation, and we'll do several examples. So, solve the linear equation. First step, perform the distributive property to get rid of the parentheses. Then, steps 2 and 3 are one combined step. They're both combining like terms. Combine like terms on the left side of the equation, combine like terms on the right side of the equation. That really wouldn't need to be separated like that unless you have variables on both sides, which we'll get to in a second. Same thing with step 4. Move the smaller variable to the side with the larger variable by adding and subtracting. Again, that's only necessary if you have variables on both sides. Get rid of addition or subtraction by using the opposite, and then get rid of multiplication or division by using the opposite. So again, what you have in the problem is going to dictate what you do. What you have will dictate what you do. So starting with example 1, 8n minus 11 equals negative 59. So no parentheses, don't have to worry about it, don't have to combine like terms, and we don't have variables on both sides. So, to get the n by itself, we have to get rid of the negative 11. So you're going to add 11 to both sides of the equation. That's 8n equals negative 48. So 8n equals negative 48. And then after that, 8 times n, the opposite of multiplication is division. Divide both sides by 8. You get n equals negative 6. So negative 6 is your final answer. It is important that you show the steps for solving the equation. Just putting an answer is not valid, and we'll get the problem marked wrong. It's not valid just to put an answer. Example 2. So example 2, we don't have any parentheses, but we can combine like terms. So 3n plus 7n is 10n. So 10n minus 15 equals negative 77. There's no more like terms. We don't have variables on both sides. So we can move over to getting rid of negative 15. So to get rid of negative 15, add 15 to both sides. So that's 10n equals negative 62. So once again, you have a variable next to a number. That means multiplication. The opposite of multiplication is division. Divide both sides by 10. So you have n equals, so negative 62 over 10, that can be reduced by dividing it by 2. So that's negative 31 over 5. Or, this is a problem in which the decimal value would work out nicely, negative 6.2. Again, if you're going to get a long, ridiculous decimal, don't give the decimal answer. Just leave it as a fraction. Alright, so, example 3. Example 3, now we have a situation in which we have parentheses, so let's take care of those. So 2 would multiply times 3p, that's 6p. 2 times negative 1 is negative 2, plus 7p equals 16. Now we combine like terms. So 6p plus 7p is 13p, minus 2 equals 16. Now we have to get rid of minus 2. add 2 to both sides. 13p equals 18. And then divide both sides by 13. So p equals 18 over 13. As I mentioned, if you're going to get a big, long, ridiculous decimal, don't put the decimal. Last problem 4. So now we have variables on both sides. So we'll use the fullness of the steps that are given to us. First thing, distributive property. So 17 comes down because it's not attached to the parentheses. 5 times n is 5n. 5 times negative 4 is negative 20. Equals 2 times negative 2n is negative 4n. 2 times negative 3 is negative 6. So now the distributive property is taken care of. Now we combine like terms on each side. On the left-hand side, 17 and negative 20 combine together to give you negative 3. The right-hand side, you can't put the 2 terms together, so for right now, you just bring them down. Now step 4 can be used since we have 2 variables on both sides. Move the smaller variable to the side with the larger variable by adding or subtracting. So we have 5n and negative 4n. Negative 4 is smaller than 5, so we're going to move it. We move it by taking the opposite. We're going to add 4n to both sides. So 9n minus 3, 4n's cancel out, equals negative 6. Just a little bigger just to finish out this problem. Get rid of the minus 3, add 3 to both sides. So that's 9n equals negative 3. And then divide both sides by 9. So you have n equals negative 3 over 9, divide by 3, that's negative 1/3. So negative 1/3, definitely do not get that as a decimal. Negative 1/3 is negative 0.33333 repeating. So those 4 examples are basic solving a linear equation. The physical steps to solve a linear equation. Some equations are larger than others, but it's important for you to follow each and every step. That's vitally important. So last but not least are solving multivariable equations. So if you remember, we finished up the first semester looking at how to graph in the slope-intercept form. Everything was already written in slope-intercept form. We started the second semester with rewriting back and forth with slope-intercept form. So it's important that you know how to go back and forth with the manipulation. Here's how we would do that, because this is solving multivariable equations. So step 1, identify the variable you need to get by itself. Use the inverse operations to solve the equation, and then simplify the expression if you need to. So with example 5, you're just solving for y. So y is the variable you need to get by itself. There's nothing attached to y, so that you don't have to, that means there's nothing multiplying to it. You do have 5x sitting there. 5x right now is adding to the y. You get rid of adding 5x by subtracting 5x. you subtract 5x on both sides. Five x's drop out. Y equals 9 minus 5x, or negative 5x plus 9. Probably should get used to putting the variable first, because that's slope intercept. So you might as well get used to start putting it first. So example 6 is actually pretty similar, except there's a number in front of the y. So the negative 3x would have to go. So get the problem written here. So the opposite of negative 3x would be positive 3x. Add 3x to both sides. 3x's drop out. We have 2y equals 3x plus 10. So, just as I mentioned, there's a 2 sitting in front. So with that 2, we're going to have to divide it. So we divide the left-hand side by 2, and we divide everything on the right-hand side by 2. So the 2's drop out, and you're left with y equals 3 over 2, leave it as 3 over 2, x, 10 divided by 2 is 5. 3 over 2x plus 5. So again, as I mentioned, we did slope-intercept form before Christmas break. That's where we're going to pick up as soon as we get back. That's the format we need to learn to work with. With that being said, this completes the review of expressions, evaluating, simplifying, and solving equations that you're going to need as we pick right back up on it starting in the second semester. So please make sure you keep up with your notes. Please make sure that if you need to refer back to this video, you do so, but know that we're going to hit the ground running. So if you need to ask for help, you need to make sure you do that, because closed mouths don't get fed. So you're still responsible for your own learning. That being said, I hope you have a great rest of your break, and I'll be seeing you very soon.